Hi everybody, welcome to my algorithm class, and in this class we will talk about empirical measurements. It is the subtopic of the uh, building algorithms. So I will continue step by step to explain all of the stuff about that. Recently we had a lesson about measuring algorithms efficiency, and the first part was the counting to operation. I think so. Yeah, counting to operations. Now we continue with another part, empirical measurements. So then we will continue step by step. It was the last part that we had. So measuring algorithms efficiency and counting the operations. It was 2.1.1. Now we will continue with the empirical measurements 2.1.2. It's for all from Khan Academy. So I just trying to explain all of them in clear way with the programming concept. You can also code with HTML and CSS, etc. Okay. Thank you. So we can start. So first thing first, that we can start here. The number of operation does not tell us the amount of the time a computer will take and actually run an algorithm. The running time depends on implementation details like the speed of the computer, the programming language, and the translation of the language into machine code. So when we write our codes, a machine is making such a calculation until found the answer. But this is what we are calling algorithm, that the computer has to do job in some steps. I mean, so we must give good steps that computer can calculate it fastly. That's what we are talking about. So how much operation we did, and in how many like how many nanoseconds we got the result, or etc. Okay. However, there are still times when a programmer finds it helpful to measure the runtime of an implemented algorithm. So perhaps particular operation takes a surprisingly long amount of time, or maybe there is some aspect of the programming language that's slowing an algorithm down. To measure the runtime, we must make the algorithm runnable. So we must implement it in actual programming language. Here's the translation from the pseudocode to JavaScript. So it's, as you see here, we have a function. And the function we have search list and numbers, target number, and then we have that one here, loop, and loop is starting from one, in this case zero. Yeah, then we're saying if index is less than numbers length, in this case we will have there a list of the numbers, and after that we will increase the index each time, and we will say if numbers in the numbers, we will put their index, that will count each of the index, and if the any of them is equals the target number, then it will return us the index. Like we are looking here like linear, so just think like this: in how many minutes it will found the answer. So generally we're making half time. Let's say there is 60 seconds or 1 minute, then we are looking for half minute to answer in the linear search way. Okay, we'll talk about others in the later cases. So okay, we can just continue from here. What can we do right now? We can just write our codes to implement it. But before that, maybe we can create another way to show that. Let's do this one, the program below called search list. And we have here such an operation that I will show you like how it works in the steps. So by the way, this one is doesn't work anymore. I mean, this guys doesn't work in the real programming way, that we will put another built-in function to get out answer. Okay, so let's say for that it's okay. We didn't, but it's okay for now. So let's do it together to get the answer for our first problem. First things, what I want to do, maybe we can delete all these guys and we can just write here this one. By the way, you can also see here and just say, what is that? Okay, you can say ID is, let's say, out, my out, let's say my out. By the way, don't focus on that, I'm just reading code. Let's say the amount of operation, let's say, like this, and then close it. Okay. So then let's delete this guys and just say text line is sorry center. So yeah, okay, this is here. Maybe we can make little font size. Font size we can just say 45 pixels, maybe. Not bad. Right, now let's write little JavaScript code. So first things, we must start with creating our function, and after that we will continue step by step. Let's say a variable that const. By the way, we can create our function in that way too. So we can just say search list, and we can open this. It is our function. Sorry, we can do in that way, or we can do in another way too, like to represent this. No problem, we can do it also in that way. So we can just say const search list, and we can put their numbers for the count in that. And the second one is target number, which is we will try to check if they are equals to each other. Okay, target number. So as you see, we already have it. We can come and we can create a loop here. So to be honest, we can just say for, and we can just say const. Let's say let I equals. Let's do little, which like I is less than numbers in this case, because we will count our index in the numbers, but numbers length. Okay. And we will increase the numbers each time, I mean indexing each time to see a result. Then we can just say if, by the way, I can bring it here, if our number and sorry numbers, and we can put our I in that, this index is equals to what target number, right? Target number, then we must return I, right? Return I, but in this case we are using HTML structure. We can just say for here document dot get element by ID, and we can just put there the ID of the my out, and then, by the way, let me do it like this, it will be clear. And then we can say inner HTML like this, and we can just put what? In this case, it will be our number, but we can't do it in that way now. So it will be I, as we know. So we can just say I. But before doing that, let's take it a little long way. Okay. I hope you can see here. So then we can come out of that and we can say return -1, return it in -1. So right, now what we have loop and etc. We put everything there. Now the time to put there the numbers, but before numbers we must put there start time stamp, because we are measuring in the time. We need like starting time and ending time. We will put our numbers between them to check each time in the loop, like what's going on. Okay, just no worry. I know it's a little bit strange and mixed, but just wait. I mean, don't confuse on that. Okay, wait me. So now we can just say war. Right? We can just say let and start time stamp like this, and we can just put here one function. I told you it doesn't work in that way. I mean, where is that? This one. It doesn't work in that way. Okay, in JavaScript we're using performance dot now we saying performance dot now. It was the starting time, and we will put our numbers now in that place. We can just say search list, and then open that. We can put our numbers like 3, let's say 37 and 45, 57 and 93, 120. So we are looking here for what? For 45. 45 is the third index or the second index if we are counting from 0. So now we will do the same process. Let me take it a little down like this. We can see all the things here. We can just say now end time step and time stamp like this. Now we can just say again performance, the same thing now, because it will give us ending time now, and it's okay like this. So now we will put their execution things like, let's say const. We can just say execution time, right? It's equals to end time stamp minus start time stamp, right? So in this case, we are tagging the start time step. The end time is here the ending time, but after this numbers operation. So just think, we just making such a subtraction operation in here to minus this start time stamp, okay? And then it will give us the measuring time after in that search list, okay? So all right, now what we can do, we can put our things in here. Now we can out this things, okay? How we do that? We can do one thing. What can we do? We can just say document dot get elements by ID, and then we can put the ID there. Let's say again my out is the ID. Let's say like this now, inner HTML, and you can just put there execution time. But before that, maybe we can do such a things there, like what? Let's say another const, and we can just represent here what we want to write there. We can write what we can write execution time, but let's do it in here. Okay, we can just say execution time, execution time, and then we can put plus, and we can put our execution time variable, and we can put another, and we can just say milliseconds in this case, milliseconds, like this. Okay, so as you see now we have all structure. So my out is there, the amount of operation. To output that, we can do such an operation in this case. But as you see, we have another variable. There is also, we return it I, this one, together. We can just put here another one down. Okay, my out one, let's say my out two, like this. And in this case, it can be my out one, and it can be my out two, like this. So if everything okay, we can also check here what we have. search list is in here. Search list. Now in this case it will check the search list, and after that we have another stuff. We must return out. Maybe this place is not clear to return it out, because the problem may be occurring in that place. Just a minute, guys. Yes, guys, after I check it, I saw I forgot to put here the comma. Now I will fix this comma, and also I had a problem with here, so we must put here function right away, like this. Yeah, now it's like a function. Okay. So guys, as you see, we have here 2 times operation, and execution time is that one, like 0.2, etc. It's execution time. The first one is number of the operation, so the amount of the operation, and we can just say for this one, this is execution time, okay? Or if you want, we can just say here number of the operation. And we can close that like this. I think, yeah, the number of the operation is that, and let's put here this one. It will be clear now. So the number of the operation is 2, execution time is 0.5 milliseconds. So what we are saying in here, number of the operation means. So as you see, this numbers I here found our target number, second operation, the second operation. So 0, the tree is 0, and 37 is first index, and 45 is second index. So in the second one, it found here. So let's try, for example, 57. What will happen? It will say 3, and it will give another numbers, right? Let's try. Yeah, the number of the operation, like the index of the operation or number of the operation is 3, and execution time is 0.2, etc. That was the way that we did here. As you can see the codes, you can just note this. Now we can continue with the reminder part. Okay, let me go to note there. Here we found the number and we fixed this issue. So if your computer is as fast as mine, then you'll see the 0 milliseconds. It was different. That's because the algorithm takes way less time than a millisecond. Our JavaScript environment can't measure time in unit less than milliseconds. However, here's what we'll try instead. We will call search list 100 times, record how many milliseconds that takes, and divide approximate the number of nanoseconds per call. That's what this program does. Now we will look for the in the 100,000, the 1 million time, I think. Yeah, no, I think 100,000 times. So we will check with 100,000 times what will give us for the operation. So as you see, our operation same for here, and we have here again same operation that we had before here, and yeah, now millisecond for per call. Now exactly we will try here different things. Okay, so first we'll say again like end time stamps minus start time stamp, and we will make this answer, this response to this calculation divided 100,000 times, and we will look in the nanoseconds, like what is that, and we will put this answer, and we will multiply with the 100,000 again. By the way, it is not 1 million, 100,000, that one. So yeah, let's go with another one. What we're gonna do now? Oh, I think this is thousand, not 100,000. So we'll look for here for thousand nanosecond. Like we will try to find it there. So not here. Here we look here now. Yes, come back here. Sure, we did that. And on my computer that reports 150 nanoseconds. There are 1 million nanoseconds in a second, so that's quite fast in a faster language, environment or computer. It could be even faster. That only tell us the average runtime, the search list, and lists 6 numbers. We care more about how runtime increases as input size increases. However, does it keep increasing linearly like our above analysis predicted? The program below reports runtime as 6 numbers, 60 numbers, and 600 numbers, right? Okay, we will check all of the operation in them. But in here, so let's go same place. We have here now millisecond per call. We will look in the nanoseconds. What will happen with the nanosecond? So, by the way, I think if I remember good, it will be exactly 1000. So, what can we do? We come back here. So now, as you see, execution time, blah blah blah, we did here. So now for the execution time, we will have different way. We will just say uh, millisecond for per call and microseconds for per call. We will put two things there. So this is execution time, as you see. So we can just make it millisecond for per call, let's say like this. So millisecond for per call, and we will just do here this operation like 10 times step minus this, and we will multiply that with what, with 100,000, that, and after that we will look another one in the microsecond. You can just say const microsecond, mic, like let's say microseconds, seconds per call, and we can just open that and we can say millisecond per call. Then we can put time 1000. So in this case we're converting that. And after that we will find the result after converting, because now we look for the milliseconds. Now we are looking for microseconds. It's different. Okay, for that we multiplied for the millisecond per call, we multiplied with 100,000. Now for the microsecond we will multiply with 1000. I hope it's 1000, not 1 million, if I remember good. So let's look now what will happen. Just come here. We can just say it will be now what execution time. I think we will out microsecond for per call. Seconds per call. Yeah, I think this is 1 million. Am I right? It's thousand, if it's a thousand amount of operation there. Alright, for per call it's here. Yeah, this is, it will be now microseconds. Yeah, the number of the operation is that. Now let's say number of the operation change here with the 45 again. What will change in here with that? Yeah, it is something like this. We can change it, by the way, so we can do another things too. But by the way, I'm sorry, I just forget to put here if this is less than I is less than something else. So now we will try something different. Yeah. So what we're gonna do now, we already returned our I function, like the const function. So we must do another for loop now here. So we can just say for, and we can put let's say index for that. Uh, let index is equals 0, and if index is less than, I forgot to put that, by the way, I'm sorry. Index is less than 100,000, like this, index plus plus like this, and we will come in that, and we will put our search list now in that one. Okay, so in here, like this. So now our search list in this point returning in the for loop. So we say if the index is less than 100,000, that it will make 100,000 times operation to looking for the 45 in this case, and it will give us the execution time, which is in this case it is 0. It is our execution time, and number of the operation is 2. So what if we say it's 93? What will happen? What do you think? It's still 0 microseconds. Okay, so what can we do now? We can just look at other things. We can do what? So by the way, it's also depending on the computer what we are trying to get out. Let's do like 45 again. So 1 minute. What if we say happen? Just do the same. As you see, to found this 45, it's 0 microseconds, but microseconds per call. Yeah, it's 1000. So per call, that was it. Times that time 100,000. As we did, we converted, and I'm just looking what can be wrong in this operation to be sure about that. So making everything okay. So target number was the same, numbers and target number, yeah. So returning I, second operation, yeah, microseconds. Maybe the computer is so fast and it's creating such a confusing point for us. All right. I think, yes, I'm sorry that we had issue in here. We must divide it. Now we will see microseconds. It's the same. I think computer so fast. Let's say 120. What will happen? Still same. What can be wrong here? I'm just trying to understand that. I think, guys, to fix this issue, we must do one more thing in here. By the way, our flow is in here. Put here, what will happen? What will change? Uh-huh. So it found a 3 point theta. Mm-hmm. Out one is the number of the operation is 5, and let's say this is 45 now. What will be the result? It's like that. So we can also do one thing. We can just indicate here like one result empty list. Okay, like this. Like let's say let result. We can put empty list, and we can put these things into result list. The pushing method. Let's try in that way. What will happen? In that way, into here, we can also take this one from there. We can just say return return I, and we can come here, not to return. Okay, doing that way. Now in here, I think the number of the operation, we will say result. In result list, let's look like this. By the way, result list, and we can come in that. We can just say result dot length minus 1. Will I think give us the number of the operation. Yeah, it's good. All right, now it works good, I think. And it will give us microseconds. Yeah. Okay, so the number of the operation is 2, and the execution time is 0.35 at say microseconds. In this case, we can calculate that too. I mean, right. We can do with the empty result list, and we can return out all this stuff. And let's try with another one, 120 for example. So what we'll say will happen 0.65 microseconds. It's okay. All right. That's good. I think everything okay in here. Something not wrong. We had. All right. In 100,000 returning, I mean loop, in the loop 100,000 iterating this search list, it makes this operation into like 0.65 microseconds. If we try a little more, we can see different result. For example, if you say like this 1 million times, it will be 5.771 etc. Microseconds. But it is enough operation. But the computer are just fast. I think it's like that. I think we had it. Okay. hmm We didn't use this random. Why we using random here? You don't need to do random or etc. So on my computer, the reports around 150 nanoseconds. There are like 1 million nanoseconds. I think 1 billion nanoseconds in a second. So that's really quite fast in a faster language environment or computer. It could be even faster. That only tell us the average runtime the search list on a list of 6 numbers. We care more about how run increases as input size increases. However, does it keep increasing linearly like our above analysis predicted? The program below reports the runtime for 6 numbers, 60 numbers, and 600 numbers. We can do that together. Like what? We will do that together. No worry about that. So let's go back. Let's say, okay, we will do that and we will continue about list size. Let's go here back. Everything will be same about here. It's okay. So, but we will indicate another function. Maybe we can change this function like measure and time function. Let's take all of them out. This guys. Now we have one function in here. So as you see here, well, I would like to show you in that way. Now we will have another operation, another function. So we can just say function measuring time like this, and then measure runtime. Sorry, measure runtime, and then we'll put in the in here list size and number of calls, and output elements. It will be our elements that we want to document with the HTML way. Okay, let me take a little back, and we can see everything clearly. So the first things first, that we must indicate the empty list with the numbers. We can just say let numbers equals empty list like this, and so we can do stuff slowly. So after indicate that, we can open another loop like let's say that I equals 0, and if I is, in that case, if I is less than number of calls, first we'll use that one, number of calls, and we will increase I in that way, and we will put our search list in that search list, and we can just say numbers and we will put also target number, I think, in that target number. So why we put here numbers and target number? So we will put their list and our target number after all process, because as you see we already had it in here. So we will just now check with another case all these things. Okay, so just don't confuse that we put it in here and in here it's same. Just don't confuse with that. Okay, you can open that. By the way, sorry, not open. We can just put it like that. And by the way, one more thing, we can just say for the num calls, in this case We can use different techniques. We can do what, I think we can say it is list size. First, let's use list size, then let's do the same operation with num calls. Then we can continue step by step, I think, because otherwise it would be little difficult. So let's, I can put it below, but I don't want to confuse you with that, okay? Just tag it out like this. Let's start first uh, with like this. Okay, let's put there first again for loop and list size with the list size for let I equals 1. Let's say in this case the index will start with a 1, and then we can just say um, and we can just say what we can just say if I is less than less than list size, that our list size here, because we'll put there 660 or 600, right? So we can just say plus 1 because we had it like 1 in this case, so index will be 1 more. I will tell you why we started with the 1, why not the 0, so we'll talk about it. And we can just say I plus plus, we can comment that, and we can now make operation. We can just say, by the way, take this for loop next to this let function. Oh my god. Okay. So now in here we can just say what we can just say numbers. So now we will use this numbers in here, but this one list that we created here, numbers dot push what I, right? This I in that place. So after we push this I in the list, and our list size will be there. If you put there 6, it will be 6, 60 will be 60 in the numbers in here, okay? So we will work with that, just no forget. Now come out of this for loop, yeah, in here. So now we can continue with the indicating another stuff. We can just say our target numbers. Now target number is important because it will be connected with the list size. What can we do? We can use math function with the floor, and we can also do it random to put numbers in the integer way. We can say let's say let target number, let target number, and we can just say math dot no, we can just say numbers. Sorry, first we can say numbers in this list that we created. We can put in the list like math dot floor to get the floor number of the list, but before that we must say math dot random, because we need to make it randomize, right? But with what? With the list size. So in this case we can put for the list, let's say 5, it will be by 5 plus 1, and then we will uh, put the, let's say 653, it will be 650 like this, 600, sorry, 650, 53.32, etc. It will be 653. Okay, so now we can say list size like this. We can close our list in that case, and we do what we do again our operation with the starting the time step by step. How we do that? We can just say let's start mess time in a second like this. Like this, and we can just say performance dot now. Let's come down. Okay, we fix it. Now we can open another loop. Uh, so in this loop, as we did that number calls, we had it, you remember, right? So now we will work with that one to understand the structure. We can just say, um, we can just say, measuring runtime is there. Second loop. By the way, did we close this loop? Yeah, we had it. There's another one. It's there. Why we have one more? Now, maybe. Let me put if something wrong. So now we can say again for I, let I equals, in this case, will be equals 0. If I is less than number calls, num calls, num calls means that we will put there, as you remember, like in how many operation, I mean like iterating these numbers. Let's say, as you remember, we put there 100,000. So now we're making these things with the function, okay? The list size is our list size. Like, are there like 50 numbers, 60 numbers, or 70 numbers that we are trying to get the target number in the list? And the num calls is in like, let's say we want 100,000 times this operation, and the last one, as you know, it's output elements. Okay, we are looking here for the execution time. The first one is that just list size. The second one is the iterating size, like how many times we want to iterate it, that we created. The first thing, this one is talking about list size. The second loop, it will be about iterating time. Okay, so I know it comes in your ear a little strange, but just wait. Step by step operation. We will now, let's say num calls, it's here. Now what we're gonna do with that one, we will increase that, and we will come in that, and we will say our search list now will be here like this, and we will put in the search list what? In the search list, we must put like this, sorry, numbers. Search list, by the way, function, not other. So numbers, the first one will be numbers, the second one will be target number. We had it already up, I know that, but let's do that. Okay, target number, because we're doing it in the num calls, I mean like with the for loop in another operation. So we will put there something else after this codes. I will show you. So we also created this one, and this is ready for working on that. I think now we can come out of this one, maybe, or let's wait there. You remember we had one more, I think. Okay. Now let's come here. Looks very bad. Alright, so now what we had it two. Now we need to make another operation between these things. So we can just create what? We can just say, by the way, this guy is still there. Oh, here. Okay, we can say let end mass. Now we already put their start. Let's do same after we had this operation. Now we will put ending time. Okay, so we can just say performance dot now. Let's do it and come down, and we can just say let mass per call, and we can put in that, as you remember, and mass and max minus start. Then we can divide it to the num calls. Or you remember what I had here with the num calls. So it was exactly in here, right? If I is less than number of calls, let's say in this case we will say like 100,000 times we want to iterate this, right? It will be like ending time minus starting time divided to 100,000, for example. Okay, why we created this function? Because we want to apply many more operations for that. If we would do same operation, it would be easy to do with one thing, but we created this function to make another much operation, okay, at the same time. So as you see, we fixed that one too. And after all, now we can look for the execution time step by step. How we do that? So we will exactly work on the bring it there. We can just say we can fix, by the way, this one with let's say we can put execution time there. I think first what we can say document dot get elements get elements by ID. We can put execution time in here, like my out one can be our first operation inner HTML. Okay, then we can just put for this what we can just say execution time and we can put that plus, and we can just say ms per call. So why we set ms per call? Because we are looking the time, like what time it will give us the execution with the number calls, because we'll put maybe there 1,000, maybe 100,000, maybe 1,000,000 or etc., right? So then we can just say dot to fix it. We will fix it to 6 in this case, let's say. Okay, we will talk about it later. And we will say milliseconds per call, like this. Okay, so now we can come down out of the function, and we can just output each of the things step by step. But in this case, we will put here something more. We can just say this is now age. Let's say h1, sorry, h1. Okay, h1. And here we need three things. Okay, now let's say this is measure time like empty, like empty like this. And this is my output 1. Let's say my output 2 and my out is 3. So my out 1, 2, 3, it means that we will make 3 operation. For that I had it like this, like 3 times in the function we will try things. Okay, so I think everything clear in here. Just we can make in here like h1, sorry, not h1, like this. We can just say text line the center, yeah, like this, and maybe we can make it 30 better. Okay, by the way, let's put an empty right here, right here. Okay, now let's come here. Let's say step by step document dot get element by get element by id, and first put my out one and say inner HTML, and okay, step by step we'll put all of them. So like what? Put them like this, and change their IDs like this. Good. So now we measuring runtime, right? We can say measuring time, run time for 6 operations, right? We can also do in another way, but anyway, measuring runtime 1, let's say for that. And now we can put this, and we can just say measuring, measure run time. This is our function. Now we will put for each of them some value. List size, in this case we want list size is 6, first one. And how many calls we want, like in here we indicated number of calls. Or you remember that? See, it was here, number of calls. This number's target number was there. It will be 100,000 in this case, right? For the 6 list item, we want to iterate it in 100,000 times, and we can put our output there, but we don't need anyway. So we can also say like result 1, result 2, result 3, etc. But yeah, we already had it there. But I think we can just also delete this output elements. We don't need that. So guys, now this is first one. Let's say do same operation for each of them. I think we can just remove them and copy paste. We can just say this is output 1, and this is 2, this is 3, this is for 60 list size, and this is for 600 list item. So look, for the 6 list item, we will make iteration for like 100,000 times, and we will look execution time in millisecond, I think. And also for 60 list item, which is we increased in here our list items, we will iterate it again 100,000 times, and we will check what's changed, how many late, like how much late, and with the 600. And we will look in the linear search how it works, I mean, okay? So let's say this is 3, and this is 2, sorry, 2 and 3. As you see, we had all this stuff. I think everything okay there. You hadn't something wrong. Am I right? My out 1, my out 2, and my out 3. Okay. So to get output, what we do? Everything looks normal. Out 1 ID, second ID, third ID. Okay, let me check that, please. Yeah, guys, now I'll try to show you the problem here that I had. In here, I must return it in the, not this way. I can do out, put display for that. I can just say return for this process. I can return it into this measure runtime function. I can return it out, and out I must do also one iterating things there. So I can just say document dot get element by ID, and then I can put M1 for the first one. Inner HTML plus equals, we can use plus equals to show each of the parameters into measure runtime function, runtime, and just say 600,000 times, like this. What is wrong? This one. I think it works now. Same things I should for. Anyway, let's put for the last one this. I should say this is my out 1. This is second one. Alright, we got already output for that. And okay. This is third one. It is my out 3. Okay. All of them different, but we will change. The list size in here will be 6, in here it will be 60, and in here will be 600 times. Okay, as you see, the numbers will change there. So now the last one, we can put M1 in here. M1, sorry, MT. And it will give us the main operation things. Yeah, the amount of operation. But by the way, it's not the amount of the operation. Now we can put it empty like this. So the things looks different. but no worry. Okay, so as you see, these guys are the same, you can think. Sorry, this one and this one, I think. No, this one and this one, right? This one and this one, which is this one and this one. So it's for 6, this is for 60, and this is for 600. But maybe we can delete this one. I mean, it's not mindly in here. If we do it in that way, what will happen? Now, by the way, we need to put there this to show this millisecond for per call for each of the operation. And we don't need to show empty. Yeah, okay. Now it works because we're returning ms per call to fix it 6. Then we're doing such operation in here with that one. Okay, as you see here, for the 6 list item in 100,000 iteration, it does in 0.000205 milliseconds per call. And not by the way per call. Yeah, I think per call is mindly that way. For the second one, 60 list item made it little late, as you see, 0.003469. And the last one is 600 list item with 100,000 times, which is, you can think, the numbers, in that case we set in here, if numbers I index found this target number, let's say if the list item is 600, then it found it in, let's say, 300 repeating, you can think. Okay, in 600 it found it in 300. Just imagine it like that. And another one is for 60, and for 6 you can just think for 6 it's like 3, let's say, but it making iteration 100,000 times, and it gives us this solution. And the last one is, as you see, much late than the others. This is the answer of this problem again. By the way, sorry, it takes little time, but it is little complex. I mean, not easy to find directly. Now I would like to show you, okay, we had it. So list size is 6, it maxed it in 50 nanoseconds. So by the way, in here, we must put for the ms per call 1 million to see the nanoseconds in the nanoseconds, okay? So as you see, we had here number of calls, it's now 100,000. What if we do it like, if we measure it with that another way, 1 minute, let's see here. First, we made this number of calls operation, and we said return nanoseconds per call. So we can check also with nanosecond how we do that. So we can just convert it in the nanoseconds, right? So as you see, it's already here. If you want to find here nanosecond, we can do such operation to see that. So we can just say numbers call to fix it. Before that, we can just say again, let's say that, let's see here, for the output case, number ms per call time 1 million. So what we do in here, we can just say nano per call, let's say. If it works, we can just say ms per call time 1 million. Convert it to the nanoseconds. So as you see here, it already gives us that, but we can just say nanoseconds, and we can just change it with this one as that. As you see, what will happen the result now if it works? What it says. Or let's do it ms per code, fix it 6. Let's say time and like 1 million, and remove that one if it works. I think something wrong here. 4, 6. It gives you 50. Why it's not like this for me? I think we can do another way. Let's take all this operation back. What can we do if we want to find the exact result in here? We can just can get in parentheses. We can say time million like this. We can just say nanoseconds per call. In this case, I think all will be the same. I don't know what's wrong in here, but it's to fix it 6 and it's nanosecond now. What will happen? The result is the same. I think it comes later. I don't know what's going on in here. But we can check with the linear search rate. If it is equals, then we can understand it works in good way. What can we do? We can come here. Let's say this is our list in this case. So we have 7,000, let's say to 8,000, and we have our calls 660 and 600. Let's check it together. Let's say we have here this, and let's say from here also this, like this. Let's do it little, okay. And let's go back. Okay. Let's say like this. Four thousand, 3,000, 3,000, and 1,000. Okay, let's do it in that way. Let's put it here. Let's see if things is not wrong. And we have here number of calls. Okay, okay. Okay. Now let's try to understand what is going on in here. Let's take it a little right like this. Okay. So we can indicate the points first. For 60, for 6, our call is what? 461. 461. Let's say it is exactly here. And for the 6, we can just think 6 is here and 461, let's say it's here. Okay. The second one is 1879, 1090, let's say, for 60 operation. 1000, it is for 6. For 60, let's say this is something like here, I think. Like here. Like 960, sorry, like maybe here. And for last one is it was 7,800. Let's say 7,800 for 60 call. 7,800 something. I think here. Okay, if we think this is exactly here, let's say here, 60, then can we do it like this, maybe? Yeah, okay, just think this is here.